Hi guys, you're welcome to my channel. Today I'll be talking about a simple machine. I'd like you to watch this to the end and drop your question in case if you have doubts about any of the concepts I'll be explaining today. If you are yet to do that, don't forget to subscribe to this channel. Like this video, drop your positive comment and share within your friends. Cool. When you talk about machine, we all know by definition that machine enable us to do work faster and conveniently. Now, what are those things that we call machine? Anything that when you apply force at one of its ends and it results to work done at the other end. How together now? When you apply force at one end and that force you apply at one end results to work done at the other end, we call such thing a machine. So by definition, machine is a device that a force applied at one end results to work at the other end. So it makes work conveniently. Cool. Now, what are the general characteristics of a machine? When you talk about the general properties, of a machine, we have the mechanical advantage. We have the velocity ratio. This is abbreviated as MA, while this is the same thing as VR. Then we have the efficiency. So we'll write this as EFF. Are we together now? So these are the general properties of a machine. So if you want to know how effective or the amount of work that has been done by a machine, you can just justify that with these properties. Now, what is mechanical advantage? Mechanical advantage is given as the ratio of load divided by the effort. Or you can say it is the work overcome over, okay, let me put it like this. Instead of work overcome, let me put it as force overcome divided by the force exact. Are we together now? That is the reason why we called mechanical advantage force ratio. So another name for mechanical advantage is what we refer to as force ratio. Are we together now? So it's a scalar quantity because it is what? Ratio. Are we together now? So mechanical advantage is load over effort, or you said what? Force overcome divided by force exact. We can also say that our mechanical advantage is the force input the force output divided by the force input. The force output divided by the force input. So all of these are definition of our mechanical advantage, and it also stands as the formula in calculating mechanical advantage. So the next thing to look into now is the velocity ratio. Now when you talk about the velocity ratio is the effort distance divided by the load distance. So this is called the distance ratio, or you call it the speed ratio, whichever one. So velocity ratio is effort distance divided by load distance, and we call it the distance ratio, or we call it speed ratio. It's also a scalar quantity, that is, it only has a magnitude but no direction. Do we get this now? Cool. So our efficiency in percentage is given as mechanical advantage divided by velocity ratio. Do we understand that now? Cool. So we can say it is the work output divided by the work input multiplied by 100. So efficiency is work output over work input. Are we together now? So that's the definition of efficiency. Okay, so but for every machine, provided that we are not neglecting friction, for every machine, provided we are not neglecting friction, efficiency cannot be 100%. Now the question is, why can't efficiency be 100%? Efficiency of a machine cannot be 100% because the load is affected by friction. The load is affected by friction. Now, I want you to understand something. I don't just want you to cram the reason behind efficiency not being 100%. I want you to understand this now. Now, mechanical advantage is depending on load. Now, friction is affecting load automatically. Friction will be affecting mechanical advantage. Therefore, mechanical advantage is said to be less than velocity ratio. So, number one reason is because mechanical advantage is less than velocity ratio. And what makes that possible? Because friction is affecting mechanical advantage, but velocity ratio is not depending on friction. Another reason is because of friction again. In a nutshell, the main reason why efficiency of a machine cannot be 100% is because of friction. Why? Friction is affecting mechanical advantage and it results to a decrease in mechanical advantage while velocity ratio is greater than it. Also, some work done by the machine has been converted to heat energy in form of what? As a result of friction. So friction converts some of the work done by the machine to heat. Therefore, efficiency of the machine reduces. Do we understand that now? Those are the reasons why machine cannot work 100% efficient. Now, we talk about the classification of machine. When you talk about the classification of machine, we can classify machine into two. We have the basic machine and we have the general classification. These are the two ways in which we can classify a machine: basic machine and general classification. When you talk about basic machine are those machines that other forms of machine are made from them. That is, you produce other forms of machine from basic machine, and they are just three in number. We have the lever, we have the inclined plane, and we have the hydraulic press. Do you understand this now? So basic machine are machines that produces other forms of machine: lever, inclined plane, and hydraulic press. But when you talk about the general classification, we can classify a machine as a lever. We can classify it as an inclined plane. We can classify it as hydraulic press. We can classify it as a seesaw. We can classify it as a screw. we can classify it as a wheel and axle. Those are the general classification of a machine. Do we understand this now? Cool. Now let us now look at the classification by level. When you talk about the classification of level, you can classify level into 3 classes. Are we together now? So we have the first class level, classification by level now. So we have the first class. Now when you talk about the first class level, we call them the EFL. Are we together now? The levels, first class level, are called EFL, where E is our effort and F is our fulcrum and L is our load. Now, what are their characteristics? That is the characteristics of the first class level. Number one characteristics is that the fulcrum is always in between what? Effort and load. You will always find your fulcrum. Fulcrum is the same thing as the axis of rotation. It's always in between effort and load. And secondly, effort and load are opposite each other. Effort and load are opposite each other. And lastly is that load actually is always closer to the fulcrum. Load is always closer to the fulcrum. Do we understand that now? Cool. Okay, if that should be the case now, we have this diagram there for the first class level. This is the fulcrum here. Okay, for better understanding, I have the fulcrum here, and here is my load, and this is my effort. So if you look at the fulcrum and the load, they are very close to each other. Reason being that the main reason why we use level is because whenever load is closer to the fulcrum, the best machine to use is level. Do you understand that now? So for the first class level, we have the fulcrum in between load and effort, and also load is closer to the fulcrum while load and effort are in opposite direction to each other. What are the examples of machines that are in this caliber? We have our scissors, the pincher. When you look at those two materials or those two machines that I made mention of, they have their fulcrum in between the effort and the load. Are we together now? So, and I think I have a scissors around here, so I can just show you it. So, if you look at this now, here is where we apply our effort, and this is what? This is load. If you look at it, the load is quite closer to the fulcrum, while the effort is far from the fulcrum, and the fulcrum is in between the load and the effort. Okay, let's say this is the load I want to cut now. You can see it's quite closer to the fulcrum. Are we together now? So it is an example of a first class level. So we also have a clown hammer, seesaw. They are all examples of a first class level. So let's move on to the second class level now. Second class level. We have the ELF. Second class level now, ELF. When you talk about the second class level, we need to understand the fact that for second class level, the characteristics is that the load is in between the effort and the fulcrum. The load is in between the effort and the fulcrum. This is effort, this is load, and this is the fulcrum. Remember, the fulcrum is the axis of rotation. So that's the first property. Load will be in between effort and fulcrum. The second property is that load and effort, they are in the same direction. That is, they are in the same side. They are in the same side. Unlike this now, they are opposites to each other. But when it comes to second class level, they are in the same side with the load closer to the fulcrum. The load is closer to the fulcrum. That's the third characteristics. And what are the machines that we have in this class? We have the wheelbarrow. Are we together now? We have the bottle opener. We have the nut cracker and the likes. Those are the examples of machines in this second class level. So we can just use the diagram to represent it here. So if this is our fulcrum, here we have our load, and here we have our effort. So you can see that the load is closer to the fulcrum while the effort is far from it. Then for the third class level, we have the case with difference now. We have LEF. All together now. That is, the effort is in between the load and the fulcrum. Effort is in between load and fulcrum. And the effort is closer to the fulcrum compared to the load. Are we together now? So the first characteristics is that effort is in between load and fulcrum. The second characteristics is that the load and the effort, they are in the same side. And the third characteristics is that effort is closer to the fulcrum. Thus, if I have this to represent it, I have my fulcrum here. So if this is my fulcrum, here will be my effort, and this will be my load. Do we understand that now? So one of the examples of machine in this class is the forehand of a man. We have distance magnifier to also be in this class. Knife is also in this class. Are we together now? So those are examples of machine in this class. Now that we've understand the classification by level, we can now consider another type of machine. But before we go into another type of machine, I would like us to consider how to calculate some examples or some questions that involves level. Okay? So now let's take for instance that I'm given a level, and here is the fulcrum. So I have here to be my first input. From here to this point is going to be my lever arm. Are we together? And from here to this point here is also going to be lever arm. Are we there? So this is first input. Are we there? And this is going to be first output. Are we together? Okay? First input, and this is first output. Now, if I want to calculate, probably they ask me to look at the value for the first input, or they ask me to look for the value for the first output. All I just need to do is to take the moment of this and this. So if I take the moment, I will have that the first input multiplied by the lever arm. Let me call this one D1 and call this one D2. So the first input times D1 must equal to the first output times D2. So you can then make whatever you want to make the subject of the formula. Are we together now? Okay, so this is this about this. Do we understand that now? So whatever you want to make subject of the formula now, you can then go ahead to make that. And if you remember, when we talk about our mechanical advantage, we said mechanical advantage is equal to the first output divided by the first input. So if you're asked to calculate for the mechanical advantage of this, you can go by this formula. Are we together now? Cool. So we can go to the next type of machine now, which is the inclined plane. So when you talk about the inclined plane, that is another type of simple machine. If I have something like this, let's take for instance, I have this, and I call this point A, B, and C. And talk about an inclined plane. For instance, this is an inclined plane now. If I have a load, let's take for instance that this is a load of 5 kilograms, and my intention is to take this load from this point here down to point A. You know, for me to take this load from this point to point A, I can either take two directions. Either I take it from B to A, or I take it from C to A. Now, when you talk about machine is a device that makes us do work easily. Are you getting this now? That is, you do work conveniently. And for you to do work conveniently, it means you are applying a lesser force in doing that job. Cool. Now, if I call this point here 5 meters, that is, the height of this inclined plane is 5 meters, and I call the distance from C to A, I call it 10 meters. Are we together now? Cool. Now, if I want to take this body to point A, like I said earlier, I can either take it from B to A or from C to A. Now, the question is on to you. Where do you think it will be more convenient? Is it going to be from B to A or from C to A? Mind you, the one that requires the lesser force is the more convenient one. Mind you again, the work that you are going to do from taking B to A or from taking C to A is the same thing. Now, let's move and see how it's going to be. Let's take for instance that I want to take it from B to A. This is the work here. The body is 5 kilograms and I want to apply a force. If I'm applying a force F, this force, I can call it an output force or input force now. Let me call this thing F. The minimum force to raise a body is a force that is equivalent to its weight. That is the minimum force required to lift a body. Now, if the acceleration due to gravity is given as 9.8 meters per second square, that shows that for me to lift this body from here to this point, I need a force of 5 multiplied by 9.8. And what would that be? Okay. So, 5 multiplied by 9.8, that will give me 49 Newton. So, I need a force of 49 Newton to take this body from B to A. Now, what is the work done here? The work done is going to be force multiplied by distance. Therefore, I have 49 multiplied by 5. So, 49 multiplied by 5 will give me 245 joules. Mind you, the work done in taking this body from B to A is the same thing as the work done in taking this body from C to A. So, if this work done is 245, then I can know the force that will take this body from C to A by saying the distance here is 10 meters. So, the work done is 245 to equal F multiplied by 10. Therefore, F equal 24.5 divided by 10, and this is going to give us 24.5 Newton. So, it means that a force of 24.5 Newton is what will take this body from C to A. So, by the time you compare the two forces, you will see that the force required in taking the body from B to A is greater than the force required in taking it from C to A. Therefore, you can do the work more conveniently by taking the body from C to A. And that is the advantage of using an inclined plane. If you look at this plane now, is inclined on this. Whenever you incline a plank on something in order to lift that object, you do the work more conveniently. Therefore, I can call this one my force output, and I will call this my force input. Okay, if that should be the case, my mechanical advantage can then be calculated as the force output divided by the force input. Therefore, I'll be having 49 Newton divided by 24.5 Newton. So the mechanical advantage is going to be so 49 divided by 24.5. So our result is going to be 2. So the mechanical advantage is what? 2. And this simply means that the force required in taking the body from C to A is going to be 2 less than the force required, twice less than the force required in taking it from B to A. Do you understand that now? So we can also get the mechanical advantage by saying that MA is equal to the ramp length divided by the height. You can also use that in getting your mechanical advantage, and that will become 10 meter divided by 5 meter, and we have what? The mechanical advantage to be 2. What about your velocity ratio? If I assume that this body is frictionless, then your mechanical advantage is equal to your velocity ratio. And how can I assume, or why do I assume that there is what? Less friction here? Because the work done here is equivalent to the work done here. That is, the output work is equivalent to the input work. That shows that velocity ratio is equal to mechanical advantage. Why? Because there is no friction. And that is the question I do ask my students. When is the machine said to work 100% efficient? When there is no friction. Are we together now? Cool. So we can then move to the next type of machine, and that is the pulley. Now, when you talk about a pulley is an example of a machine that we can classify as a wheel and axles, or we classify it as a lever that has an effort in one direction. Cool. What and what do we need to realize about pulley? We have two types of pulley machine. We have the movable one and the fixed one. I'll be considering the two separately, of which I'm going to be starting with a fixed pulley. When you talk about a fixed pulley, okay, permit me to take the diagram somewhere. So if this is a pulley now, and then I have a load, and here is my effort. Okay, I think I can have a perfect diagram like this. So this is the load, and here is the effort. Guys, I would like you to understand something here. When you talk about a fixed pulley, the mechanical advantage is also equal to its velocity ratio. Are we together? Why? Because there is no friction. Therefore, the work done at this end must equal to the work done at this end. How do I get my mechanical advantage? My mechanical advantage is equal to the number of rope. Mechanical advantage is equal to the number of rope. And you can also say that velocity ratio is also the same thing. But whenever you have a fixed pulley, the number of pulley is going to give you the value for your velocity ratio for a fixed pulley. for a fixed pulley, number of pulley is, okay, velocity ratio is equal to the number of pulley. Do you understand that now? Cool. Okay, this about a fixed pulley. And mind you, the tension in this rope here will be the same thing as the tension here. So if this load is 200 Newton, are we together? This tension is going to be 100 Newton. Why this would also be 100 Newton? Because the minimum force required to lift the weight of a body is the force that is equivalent to its weight. Are we together now? Now, what if the pulley is now a movable one? How do I calculate for my mechanical advantage and my velocity ratio? Okay. Let's quickly consider this diagram here. If I have this as a load of, okay, I think this is not there. This is a load of 400 Newton. And I have this to be my rope. And then this is a pulley. Okay. This pulley is a movable pulley. And this is you that you want to pull this particular crane. Now, if this is 400 Newton, remember, the force required to lift a load is the force that equivalents its weight. Therefore, the tension in this string is going to be 200 Newton, and it has to equal to the tension here, which is also 200 Newton, because this one is 400 Newton. Are we together now? Therefore, this man needs to apply effort of 200 Newton in lifting this crane. And by definition, a pulley is a machine that double the input force. Whatever force you put in it is going to double it. And if you look at this, if this is 200 Newton, this pulley has helped you to multiply it by 2 so that it can lift this body. But it doesn't just multiply. You also have to do something. And what is that in? You will understand that now. Let's take for instance that this body, this particular rope, push this crane upward by 1 meter. That shows that this one is pulling it up by 1 meter and this one is also pulling it up by 1 meter. And that results to the length of this rope to long by 2 meters. It shows that for you to make use of a pulley, you have to drag the string or the rope to a far distance. So when you draw it to a length of 2 meters, this is going to increase by 1 meter. Do you understand that now? Cool. The mechanical advantage is equal to the number of rope. Number of rope. So if I want to know the mechanical advantage, I'll just count the number of rope I have, which is what? 1, 2. So the mechanical advantage equal to. If I don't want to go by that, I can say my mechanical advantage is the force output, which is 400 Newton, divided by the force input, and that will just give us 2 at the same time. Do we understand this now? Now, the work done at this side is equivalent to the work done at this side. How? This one is force times distance, and that is 400 Newton times 1 meter. So, we have this to be 400 joules. And here also, the distance here is 2 meters multiplied by 200 Newton. This will also give us 400 joules. We assume that this is frictionless. Do we understand this now? Good. If we truly get this right now, how do we then calculate for the velocity ratio? The velocity ratio is given as 2 to the power of n. So, if the velocity ratio is 2 to the power of n, what is the value of n? N is equal to number of movable pulley. Are we together now? So we only have one movable pulley here. So N is equivalent to 1. 2 raised to the power of 1 equal 2. And you can see that it's also equal to mechanical advantage. Why? Because there is no friction. Do we understand this now? Please, before we look at the second example, let me check my camera. Okay guys, let's continue please. So the second example now, you will pause the video and tell me what the result likes. Okay, if I have this now, and here is a crane of, let's say, 800 Newton. If this is a crane of 800 Newton, and here is a pulley, and here is another pulley, and here is another pulley. So this is you now that want to drag the pulley up. Okay, so how do we go about this? Mind you, if this is 800 Newton, it means that this rope is going to have T to equal 1, 2, 3, 4. So this will be 200 Newton. This will also be 200 Newton. This will also be 200 Newton. And this will also be 200 Newton. By the time you add everything together, your result is going to be 800. Why is it 200, 200, 200? Because the tension in each rope has to be equal. Are we together now? So if the tension on these ropes are 200 Newton each, then it means this man is pulling what? The rope by a force of 200 Newton. Are we together, guys? Thank you if we have. Now, what are the things we want to look at here? Mechanical advantage, velocity ratio. Since we already know the input force here, then we also want to consider the work done. Okay guys, we can go on by looking into that now. Who can tell me what the mechanical advantage will be? Okay, the mechanical advantage is just 1, 2, 3, 4. So the mechanical advantage is 4. Now, if this pulley is fixed, because if you are trying this experiment in the real life, this particular pulley here would not move, although it's supposed to move, but it will not. But you have this moving and this moving, and this one will also move. Therefore, our velocity ratio is 2 to the power of 3, and that will be 8. Remember, we have a movable pulley. So we have 3 movable pulley, and that is why it's 2 to the power of 3, so the velocity ratio is 8. Then our mechanical advantage at this point is just the number of rope, 1, 2, 3, 4. So our mechanical advantage is 4. We can also get our mechanical advantage by saying this is the force output and this is the force input. So our mechanical advantage can also be 800 Newton divided by 200 Newton, and that will give us 4. Are we together now? This to tell you that when you have large numbers of pulley, your work become more lesser compared to when you have a single pulley or you just have double. Cool. Now the work done here now is going to be the same thing as the work done here. Therefore, this is going to be what? This is going to be, let's take for instance that this body move upward by 1 meter. If this body move upward by 1 meter, it means this rope is moving it upward by 1 meter. This one is also moving it upward by 1 meter. This one is also moving it upward by 1 meter. Therefore, the total distance that this man needs to drag this rope to is going to be 4 meters. Therefore, the work done here is going to be 800 joules, and the work done here would also be 800 joules. We have assumed that there's no friction. Mind you, If not for we considering it as a real life situation, then the velocity ratio is supposed to be the same thing as the mechanical advantage because there is no friction. Are we together? Cool. So, if that should be the case, we can stop the video here. And in our next video, we are going to upload some examples on machine, both the efficiency, mechanical advantage, and velocity ratio. If you like this video, don't forget to give us a thumb. If you are yet to subscribe, don't forget to do that. Thank you.